We need to find the values of the 6 trigonometric functions of the acute angle beta. C squared is equal to A squared plus B squared, and the missing side is the hypotenuse. So C squared is equal to 7 squared plus 3 square root of 2 squared. And C squared will be 49 plus 9 times 2. So C will be C squared is equal to 67, and C is equal to the positive square root of 67. Now that we have the missing side, positive square root of 67, which is also the hypotenuse, we're just gonna find the 6 ratio. Sine is opposite. The side opposite to beta is 3 square root of 2 over the hypotenuse. The hypotenuse is square root of 67. When we rationalize, we will multiply 3 square root of 2 over square root of 67 by square root of 67 over square root of 67. And our answer will be 3 square root of 134 over 67. So another version of sine beta is 3 square root of 134 divided by 67. Cosine is adjacent over hypotenuse, so it's 7 over square root of 67. And when we rationalize the denominator, we obtain 7 square root of 67 over 67. So cosine beta is 7 square root of 67 over 67. And tangent is opposite over adjacent. The opposite side is 3 square root of 2, and the adjacent side is 7. Cosine will be the reciprocal of sine, so we'll just flip. So it's square root of 67 over 3 square root of 2. When we rationalize, meaning we multiply by square root of 2 over square root of 2, we get 1 square root of 134 over 3 times 2, which is 6. Secant beta is the reciprocal of cosine beta. So secant beta is square root of 67 divided by 7. Cotangent beta is the reciprocal of tangent beta. So it's 7 square root of 2 over 3 times 2 over 6. If we replace the length of the side by lowercase letter, then we will obtain these ratio. For example, sine theta will become A over C, opposite over hypotenuse. Cosine theta, B over C, adjacent over hypotenuse. And tangent theta, A over B, opposite over adjacent. Similarly, we'll take the reciprocal of sine for cosecant, the reciprocal of cosine for secant, C over B, and the reciprocal of tangent for cotangent, B over A. Thus, we find the reciprocal identities sine is equal to 1 over cosecant theta. Sine theta is equal to 1 over cosecant theta. Cosine theta is equal to 1 over secant theta. Tangent theta is equal to 1 over cotangent theta. If we go the other way, cosecant theta is equal to 1 over sine theta. Secant theta is 1 over cosine theta. And cotangent theta is 1 over tangent theta. And when we multiply a number by its reciprocal, we get 1. Therefore, sine theta times cosecant theta is equal to 1. Quotient identities, sine theta over cosine theta is equal to tangent theta. Cosine theta over sine theta is equal to cotangent theta. Pythagorean identities, sine squared theta plus cosine squared theta is equal to 1. So right triangle. Tangent squared theta plus 1 is equal to secant squared theta. And 1 plus cotangent squared theta is equal to cosecant squared theta. Sine 40 times cosecant 40 can be written as sine 40 multiplied by 1 over sine 40. Cosecant is 1 over sine. Therefore, it'll become sine 40 divided by sine 40. And since sine 40 is different from 0, it's equal to 1. Sine 82 over cosine 82 is equal to tangent 82. Now we have tangent 82 minus tangent 82. The answer is 0. 2 sine squared pi over 8 plus 2 cosine squared pi over 8. When we factor out 2, we get 2 sine square of an angle plus cosine square of an angle. And sine square of an angle plus cosine square of an angle is equal to 1. So it's 2 times 1 equal to 2. 5 times 10 squared 2 pi over 11 minus secant squared 2 pi over 11. 5 is the greatest common factor. Now, tangent squared minus secant squared of any angle is equal to -1. So 5 times -1 is equal to -5. Why is it equal to -1? Well, remember, tangent squared plus 1 is equal to secant squared. Pythagorean identity. You take away secant squared theta from both sides, and you move 1 to the other side, you get tan squared theta minus secant squared theta is equal to -1. For number 5, 3/5 cosine over sine. Cosine over sine is cotangent. So it's going to be 3/5 cotangent 24 degrees minus 3/5 cotangent 24 degrees. The exact value is 0.